In 1981, 3 engineers founded SMA and became pioneers of the global energy transition. Their vision was to provide renewable energies to people across the globe. Our mission is now more relevant than ever. We want to shape the energy transition with your help. Welcome to Let's Talk Energy. Broadcasting live from the new Solar Academy studio at our SMA headquarters in Kassel, Germany. Learn all about the latest innovations and developments at SMA. Let's get started.
Hello everyone, my name is Bernhard Voll. I'm presenting to you today about power to gas, a key technology for the energy transition into a decarbonized world of industry and society. To do that, we need to talk about hydrogen, and that's what I'm going to explain to you today. After my presentation, I welcome you to our chat, and in the meantime, if you have any questions or want to participate in our survey, please don't hesitate to answer our Slido questions. So, as a next step, I want to show you a little bit about hydrogen. How is hydrogen generated? And for that, I've prepared a little experiment to show you how simple it is to generate hydrogen. So all we need is a little bit of water, a pinch of salt. It's actually a bit more than a pinch, it's a lot of salt. That's mainly to make the water conductive. Has no further function than just to increase the conductivity of water. Need to stir it a little bit to dissolve the salt, and then wait a little bit. And all I do now is I throw in a battery, a 1.5 volt AAA battery, and if we wait a couple of seconds, we're going to find at the end, let me show you in the detail. So over time, takes a couple of seconds, you will see some bubbles coming up from that battery, which is pure hydrogen. So that's all what's needed. It is needed DC current, a little bit of water, and you dissolve water into hydrogen and oxygen. In this case, oxygen reacts with an electrode, so you don't see it, but you can already see these little bubbles popping up, and that's pure hydrogen. That's all what is needed to generate hydrogen out of water. It's DC current. How to generate that DC current, I'm going to explain you now in my presentation, because of course we cannot use these batteries only, that would not be big enough. So we have some bigger units we want to use, and I'm going to explain you why it is so important to use SMA technology to produce the best hydrogen in the world. Before I show you my detailed presentation, let me present you a small video, about 3 to 4 minutes, about our activities in power to gas.
Decarbonization of our economy is key to reduce the effects of climate change in coming years. Hydrogen production from renewable energy sources is indispensable for reducing carbon emissions and achieving climate goals. In order to meet the demand for green hydrogen in the industry and the mobility sector, leading market research institutes expect an increase in electrolysis capacity connected to the grid of more than 150 gigawatts over the next 10 years. This substantial additional load, combined with a significant increase in renewable energy sources, represents an enormous challenge for worldwide power grids. Electrolysis for hydrogen production requires direct current for the splitting of water into its components, hydrogen and oxygen. The alternating current from the grid must first be converted into direct current. The SMA Electrolyzer Converter is specifically designed for the power conversion from alternating grid current to an electrolyzer suitable direct current. Our advanced state-of-the-art IGBT technology lowers the impact on the grid to an absolute minimum. SMA power conversion technology does not require additional harmonic filtering or power factor correction equipment like other technologies typically do. The advanced SMA Electrolyzer Converter allows optimum production of hydrogen at highest efficiency and lowest life cycle costs. The pre-installed containerized solution contains the electrolyzer converter, medium voltage transformer, and switchgear for a plug-and-play connection between the electrolyzer and the medium voltage grid. Everything already pre-installed and ready to use. For our electrolyzer converter, we leverage on our 40-year experience in power conversion. SMA has installed more than 100 gigawatts of converter power. The electrolyzer converter bases on a well-proven technology platform with a more than 30 gigawatt track record in solar and storage applications. This makes integration of renewable energy sources into the network for green hydrogen production even easier and cost-effective. The SMA solution can be applied to various use cases for hydrogen production, for example, in the steel industry, the fertilizer industry, in the mobility sector, for refineries, and many more. Our engineering team designs the electrolyzer power solution to the local project and specific electrolyzer requirements of your hydrogen plant. Our electrolyzer converters already operate in multiple hydrogen projects around the world. Basing on our existing production facilities in Germany and our worldwide service network, we are ready for this fast-growing market. The hydrogen journey has just begun. Join us in this revolution and fight climate change together.
Before I talk about the details, how to generate hydrogen with DC power, let me explain a little bit about the most versatile molecule on this planet. That's why I call it the supermolecule. 75% of all mass and 90% of all molecules on this planet contain hydrogen. Hydrogen is absolutely invisible, which is actually bad because you don't see it, you don't feel it, you don't hear it, you don't smell it. It's just not visible. It's very light. You need 11 cubic meters of hydrogen just to have 1 kilogram. It liquefies at an incredibly cold temperatures of minus 250 degrees C. It has an excellent heat conductivity. That's, for example, why it's used in generator cooling. And it has a very high energy content. The unfortunate thing of hydrogen, however, is that because it's everywhere and it's so attractive, it wants to connect to all other molecules on the planet almost immediately, which makes it very explosive. But that can be controlled. Hydrogen is extremely versatile. It's in methane, natural gas. It's in methanol, which is a perfect fuel for cars, for trucks, for trains. It's in ethanol, which is a very clean alcohol. It's in kerosene. 22 atoms of hydrogen are in kerosene, which is the airplane fuel. It's in ammonia, which is the base product for fertilizer, and consumes about, just the ammonium production in the world consumes about 4% of the global energy consumption. So using hydrogen and nitrogen to produce ammonia with renewable energy would take out a lot of our fossil energy consumption. It's in PVC, so plastic, and you can use hydrogen to make steel out of iron oxide instead of using coal coal-fired furnaces, you can use simple hydrogen to convert iron oxide into iron and water. So what are the use cases for hydrogen? The use cases for hydrogen are, of course, first we need renewable energies. So that's a given. So we can create energy required for the production of hydrogen with clean, green, carbon emission-free energy sources. Then we convert it to hydrogen in that electrolyzer, and you can use it in refineries to convert crude oil into all kinds of light liquids, into plastics, in kerosene, in diesel, in pretty much everything coming out of hydrocarbons. You can use it for ammonia production, which is the base material for fertilizers. We can use it in all kinds of industry, especially making of green steel. We can use it in mobility, for buses, for trains, for airplanes, for garbage trucks, for town trucks, for pretty much everything in mobility, ideally long distance or large mobility uses. And we can use it for long-term storage. This is also one of the key uses, much better than batteries if you go for longer than 6-hour storage. We can also use it in residential, but the key is up here in industrial uses, industrial mobility, ammonia, and refineries. Today, hydrogen is mainly made by steam methane reforming. What is steam methane reforming? So essentially, you combine natural gas with steam, so with water, and convert that to hydrogen and a lot of CO2. This is the difficulty with that process. It's a very efficient, very low-cost process, but you need a lot of fossil energies and you generate a lot of carbon dioxide, so it's not good for the planet. That's why it's thumbs down. It's not a sustainable production. Much better, it is like in the battery I showed in the beginning, is to produce hydrogen with renewable energies such as hydropower, geothermal energy, bioenergy, wind power, or like we like to do with solar power. So you only need DC power, which you can do using converters, and you don't have any carbon emission, which makes the hydrogen production absolutely sustainable. So fully thumbs up. That's why the little girl on that slide is smiling. To produce that DC power, so for the optimum power supply of these electrolyzers, we need perfect products. Keep in mind, this is a very expensive process. This is an industrial process running 24/7. So we need reliable products, highly efficient products, optimum, scalable, standardized, and especially grid-friendly rectifiers. If you connect a 100 megawatt hydrogen plant to the grid, you don't want to disturb the grid with harmonics or with low power factors. You want to make sure that green hydrogen production is as grid-friendly as possible and in the highest quality possible. And that's why we are here. That's why SMA is here, to generate and produce these best rectifiers you can find. Some technical facts about rectifiers. Traditionally, rectification is done with thyristors. Thyristors are very simple devices converting AC to DC. They have reasonably high harmonics. Therefore, they need filters. They need phase shifting transformers. They have a low power factor, which means we need power factor correction equipment such as capacitor banks. They are fully grid dependent, so each and every rectifier has to be tuned to the specific grid connection. Does this help scalability? No. They are fully grid dependent. They produce, especially at partial load, a relatively high DC ripple. At full load, they're perfectly fine. But at partial load, which you quite often have with renewables, they generate a high DC ripple, which reduces the lifetime of the electrolyzer and also reduces the efficiency. On the opposite, SMA IGBT rectifiers, such as this little box you see here, these rectifiers using transistors have ultra-low harmonics. They are below 3%, so they can work in any grid. They generate DC current at a very high power factor, so you don't need any additional equipment. You don't need capacitor banks or filters. It's all integrated in that box. We produce these rectifiers in a very high volume automotive standard production. It's a standardized product, so you can scale it. You have the capacity to produce a lot. We can increase the capacity. We can produce at a very high consistent standard across the whole year. And because we're using transistors, our DC ripple is very low. Doesn't matter whether it's 1% of the load or 100% of the load, which is good for the electrolyzer. What's our approach to electrolyzers? What you see here on that picture is our 40-foot containerized station with 2 inverters, with a transformer in the center, and with a medium voltage switchgear. So everything is included in that 40-foot containerized station. Complete systems with giving you minimum design efforts. We have a modular approach. We can add these containers, we can stack them on top of each other or place them side by side. So you have a very high flexibility in your project design. We have a very high level of standardization, which gives you high reliability. Of course, as I explained in the beginning, our grid services are included. We don't have any issues with connection, no harmonics or very low harmonics, high power factor, grid services available, so it's easy with a connection to the grid. Our rectifiers are air-cooled, so we don't need complex hydro-cooling or other cooling system. We just place them outside, install them everywhere. They're fully outdoor, so we don't need a building. So we can put them pretty much everywhere in a very short time. That's why we also say 4 times 5 is better than 1 times 20, because just keep in mind, you build this 20 megawatt electrolyzer plant, and then somebody decides, oh, by the way, I want to add another 5 megawatts. With thyristors, this would mean you need a new plant. With us, you just buy another container. And I'm not just talking about PowerPoint here. We have, since we started in early 2020, we have already quite a lot of references. Now, one you don't see, let me go down here. In New Zealand, we have a reference there. That was our first reference. This is a geothermal power station. We have references, active projects. Active projects in China. We have active projects in Europe, like in Paris, in central Paris, for the Paris taxi fleet. We have projects in Norway at the Russian border, far in the north. That's actually that photo here. We have projects in Spain where we produce green ammonia with solar electrolysis. We have projects in US. So already we have multiple references in the world, and we work with all leading electrolyzer manufacturers. These guys like to work with power conversion systems from SMA. And of course, we also work on the new technologies, on the technologies for the future, for the very large electrolyzer plants, for the new generation of rectifiers. That's already here in development in SMA with our R&D departments, because we want to work with you to generate the future of clean hydrogen production. That's why it's also not just a side business in SMA, it's a key focus area in SMA's future strategy. It doesn't matter whether it's electrolysis or fuel cells, hydrogen is one of our key areas where we want to participate in the future. So in summary, hydrogen is the future of a decarbonized industrial society. It's no longer coal or oil or gas. Hydrogen, clean hydrogen, is the key to a clean society. Hydrogen must therefore be produced with renewable energy. And by the way, maybe not in Germany because we don't have that much space, but there is enough space in the world to generate clean, green, and competitive hydrogen to run our industrial societies. For sustainable growth, we need power conversion systems for these electrolyzers, which provide a very high quality, low impact, modular and scalable solution. And that's why SMA IGBT inverters are the way to go. I'd like to thank you for listening to me. And of course, please stay in the conversation. I'm now available for the chat with you. And I hope you all answered the Slido questions so we can tune our products for the future. Again, my name is Bernhard Voll. I'm the senior technical expert responsible for all our power-to-gas activities here in SMA in our subsidiary SMA Sunbelt Energy. Send me an email if you can participate in the chat. We are here for you. Thank you very much.
Thank you for your attention. We look forward to your questions and comments during the discussion with experts. Just follow the link.